All right, welcome to the first in a series of videos, which I'm calling the Periodic Table Skills series. This is going to be for my chemistry students who need a little bit of help brushing up on some skills that we may have covered at the beginning of the school year, but for whatever reason, you didn't really quite master those skills. Now, I always say that chemistry is a snowball class, meaning you start with a little bit and it kind of just rolls into other things. And then eventually, if you've mastered all the topics, you end up being able to roll together this giant problem, this giant snowball of things that we do towards the back end of chemistry. But it's very difficult to do that if you did not do the steps at the beginning of the year, learning some of those fundamental skills, such as reading a periodic table, or even what we're covering today, which is identifying protons, neutrons, and electrons. So I hope this video will help you. I'm intending for these videos to be as short and sweet and to the point as much as possible. And so I will try to keep this short, but if you need more information and more elaboration, that's where you'll want to utilize either your slide decks, the online resources we have on Google Classroom, or just come in for some tutorial sessions either in the classroom or online, and then we can go over things as much as you need. But this is meant to be a short refresher on just very specific targeted topics, today being the first in the periodic table skills series, protons, neutrons, and electrons. So here are some of the things that we're hoping to cover in this series, and they all go together. We're going to start with being able to look at the periodic table and count the number of protons, neutrons, or electrons in any atom. You also want to be able to then draw what's called a Bohr model or a Lewis dot diagram for any element. You want to be able to identify valence electrons. You want to calculate what's called the mass number, calculate what's called ionic charge, draw off-ball orbital diagrams, write electron configurations, and just plain old simple, tell me what the name of this element is based on any of this information. And so we're going to go through this list in a series of videos, and these are all called periodic table skills. They're called this because these are things that you should be able to do using just a periodic table. Now, because we're doing a lot of online remote learning and we're using devices for our class, we've been using ptable.com, which is an interactive periodic table. It's very awesome and it gives you so much information that you can use, as well as linking you to Wikipedia pages for various elements and compounds. But in a traditional school setting, we would not be using an interactive periodic table or an app. You would be using a sheet of paper with a periodic table printed on it. So it would not be an interactive periodic table. You would instead just get something that looks like this. And so you can't click on anything. You can't do much with it. You have to rely on understanding what the numbers and the letters on this chart mean. You have to learn some of the hidden secrets and patterns of this periodic table. And that is what you would use to do all the things on that list that I just showed you. So let's get started with the first step, which is being able to count the number of protons, neutrons, and electrons in any atom. Now, it's a very simple and short to the point process. Let's start by looking at the periodic table and understanding what information is available for us on it. I'm going to identify, let's go to element number 11. It's one of my favorites. We talk about it all the time. And that's going to be the element that you're probably eating either right now or at some point today. You probably did. And that would be Na. No, that's not the name of it. That is sodium. It is element number 11 on the periodic table. And if you could zoom in, you'll see that there is another number in the square. It says 22.990 for the one on the screen right now. So when you see this on the periodic table, what information should you be able to get from just this square? There are three things here. The first should be some whole number. That's called the atomic number. The atomic number is probably the most important thing in the square on the periodic table. Well, why is that? Well, for the purpose of this video, we're talking about counting protons, neutrons, and electrons? Well, the atomic number is going to get you that information. When it comes to the protons, your atomic number is going to be the number of protons. The atomic number equals the number of protons in an element, in an atom of the element. So, for example, since the element sodium has an atomic number 11, that means that sodium has 11 protons. Now, the atomic number will also tell you how many electrons an element has in one atom. So, if sodium has an atomic number of 11, it will have 11 electrons. That's the first thing you should know. Second, these two letters are what we call the symbol. So this is the shorthand abbreviation for the element. The element that Na represents is the element known as sodium. Now, it is a whole different topic to talk about why the name of the element is sodium, but yet the symbol is Na. There is no N or an A in the word sodium. So how is this a symbol or abbreviation? Well, it comes from the language of the person who discovered the element. They named it based off of their language. I believe it might be Latin. So you would have to look that up on Wikipedia. That's something for a different day. So the element that we're focusing here on is sodium, and the symbol is Na, capital N, lowercase a. Last but certainly not least, the third number that you will see typically in the box, this is a number that will often have a decimal to it. It is called the average atomic mass. So the average atomic mass is basically an average of all the different masses of sodium. There are isotopes of sodium. These are different types of sodiums where they have different or varying numbers of neutrons. In order to tell me what this element, any element is, we need an ID number. Just like you as a student may have a student ID number that tells me who you are, elements have an ID number. That number is called the atomic number. If I know what the atomic number is, then I know what the element is. If you tell me that my atomic number is 11, that means we're talking about element number 11, and that is sodium. Now, that tells you directly the number of protons and electrons in sodium. However, you notice I have no information on this so far about the number of neutrons, the third and often forgotten stepchild of the three subatomic particles. It's like we talk about neutrons for a little bit and then they hardly ever, never come up again. Well, they are important as well. They have a role to play here. What is that role? Well, there are three things that we look at for these three things that we're talking about. We're talking about protons, neutrons, electrons. Well, there are three things about these three things you need to know. That would be what's called the charge, the location, and mass. Charge is, are we talking about something being positive or is it negative? That is going to let us know who is attracted to who, like magnets. You have to have a charge. Location is asking where does this particle live within the atom? And then mass is basically not the same as saying how heavy something is, but it is related. And a lot of people use the word weight and heaviness and mass as if they all mean the same thing. They do not mean the same thing. Mass is a measure of how much substance or matter is within something. And we use grams typically to measure that. But if I say pounds and weight, we kind of have the same idea. How heavy is something? But how heavy is something is not the same as how much is within it. Because how heavy you are on Earth is not the same as how heavy you're going to feel on the moon. However, what's inside of you on Earth will be still inside of you if you go to the moon. So the weight will be different, but the amount of matter inside will be the same. But I digress. What are the charges for each of these particles? Well, for the proton, as you can see, I've been writing P with a plus sign on it. That's because protons have a positive charge. Protons are positive. Electrons, I have written them with a minus sign. That means that they have a negative charge. Now, what does that mean? It just tells me who's attracted to who. Protons are attracted to the electrons. Electrons are attracted to the protons. Opposites attract in chemistry, pluses and minuses. Two plus signs do not want to be together. Two negative signs do not want to be together. You have to have opposites to be attracted in chemistry, that is. So then, for that third and often forgotten stepchild of the three, the neutron, as you may guess, they have no charge. They are neutral. They don't prefer protons. They don't prefer electrons. They prefer to remain single. Single and does not want to mingle. No charge. They're just there. They're where? Well, location. If you look at the many different ways that we draw an atom, I would use a Bohr model as an example. A Bohr model will typically have a zone in the middle like this, and that's going to represent the nucleus. In the nucleus is where we find protons and neutrons. They are being held together by some type of nuclear force, some type of glue that kind of keeps them all clumped together in the middle. Kind of like if you were looking at a picture of a planet, maybe Earth. In the middle, we have a molten core. Or if you think about maybe the solar system, the sun, you have planets that orbit around it. You also have a planet like Earth that has a moon that orbits around it. Well, we think about the middle of the atom, which is the nucleus, kind of like the sun. It's the middle or the core of the planet, if you want to use it that way. Protons and neutrons are there. They're just chilling. Now, on the outside of the nucleus, you have this fuzzy zone where a lot of things are flying around, zipping around really fast. It's so fast, it's blurry, it's like a cloud. We actually call this area the electron cloud. Now, it is this circular zone where we find the electrons. So the protons and neutrons are chilling in the middle in the nucleus. And outside of the nucleus, we have this fuzzy, cloudy zone called the electron cloud, and that's where the electrons are going to be. Now, where specifically are they and what exactly are they doing is a discussion for another day. But typically, these are the locations of those three. So now we get to the final part, which will be the mass. Now, these three particles are extremely small. So their masses are pretty small. As a matter of fact, if I wrote out for you just how small these three things were, I'd be writing some kind of number like this 0.0000 and just a whole bunch of zeros if we're going to talk about grams, right? That's what we use to measure the mass. So since the number is so small with so many zeros, and I mean, zeros are cool. I just prefer them to be behind a comma, not behind a decimal when it comes to that money, you know what I'm saying? But anyway, we use a unit that is better and more convenient and easier. And it's called we're not going to be creative. We're just going to call it the atomic mass unit here. Okay. So you discover something, you can name it what you want. So the atomic mass unit is a way we can tell what the mass is because grams is just, these things are too small for us to use grams. So we have another unit called the atomic mass unit that makes the numbers easier. Instead of using this, if we use the atomic mass units, then the mass comes out as this. Protons are said to have a mass of 1 AMU. Just one. One proton, mass of 1. So that's great, right? Because then if you have one proton, that's a mass of 1. But if you have 2 protons, that's a mass of 2. You got 3 protons, that's a mass of 3. You see how we can just make up units to make things easy? It works. It benefits. It's cool. It's all good. Electrons. Well, actually, let's do neutrons. Protons are 1. Neutrons also have a mass of about 1. Using this system, it makes it really easy. If you want to know how heavy or what the mass is for a bunch of protons and for a bunch of neutrons, you just add up how many you have. 1 proton, mass of 1. 1 neutron, mass of 1. You got 2 neutrons, mass of 2. 2 protons, Mass of 2. You got 2 protons and 2 neutrons together? Mass of 4. That was a 4. That was a 4 that I held, but the camera only showed 3 fingers. I do know how to add. Okay. So then what about the third one? The electron. Turns out electrons are even smaller and have less mass than protons and neutrons. And because of this system that we made up, it works out to say the mass of an electron is so small, we can ignore it. It's negligible. So we just say it has a mass of 0. Now, does that mean that electrons actually have a mass of 0? No, they do have a mass, but these things are already so small, the electrons are even smaller. So we go ahead and say, yeah, let's just go ahead and say it's 0. It's just weird, okay? Again, you discover something, you come up with the rules yourself. So electrons have a mass of 0. So if I want to know how heavy an element is, I can just add together the protons and the neutrons, and that's going to give me what's called the mass number. Mass number. So the mass number is when you add up all 3 particles, but it turns out one of them has a mass of 0, so you don't need to add it. Just add the protons and the neutrons together. And this is where the saying ape man comes in from. Ape man, which is this: A equals P equals E. That's atomic number equals protons equals electrons, as we mentioned up here. And then for the man part, there's different ways that some people write this depending on what you're trying to calculate, but this may be the one that you've seen the most. For the man part, it's the mass number minus the atomic number equals the neutrons. We know that the atomic number right here tells you the number of protons, right? So if you know your protons, you'll put that number here. The mass number will be your protons and neutrons together. But if we don't have this information for you, you might have to calculate it, okay? So it depends on the problem. But typically, your mass number will be your protons and neutrons added together. Remember that the atomic number and the protons are the same thing. It's the same number. And so that's why we can write it this way, that the mass number minus your protons gets you the neutrons, or you can say mass number minus atomic number gets you the neutrons. Why did we not write it this way? Mass number minus protons equals neutrons. Why don't teachers write it this way? Because it wouldn't sound nice when you say it. Instead of saying ape man, you'd be saying ape mapinin. And that doesn't really flow too well. So we know that protons and atomic number mean the same thing. So atomic number it'll be. So M minus A equals N. Ape man is the key. So you got the charges, which plays into things that we'll talk about later in here. You know where they're living in the atom, and now you know their mass. So what do you do with this information? You should be able to count the number of protons, neutrons, or electrons in any atom. So let's look at 3 examples together before we wrap this up. The first example I would do for you. The second example, I will guide you through it. And then the third example, you should do. So let's take a look. I'm going to think of 3 random elements. Actually, not random. Today, this is the month of November, which is month number 11. Today is the 17th, and the year is 2020. So here will be our 3 elements. So I want to know what the name of these 3 elements are going to be. I want to know their protons, the electrons, and the neutrons. And this part with the neutrons will get a little bit more complicated, as you're going to see in a second. Because remember, on the periodic table, we said that you have atomic number, the symbol, and then something called the average atomic mass. The average mass. So when you look at different types of sodium, yes, there are different types of sodium, isotopes. When you look at all the different types of sodiums, some of them may be heavier than the others. We take an average of all their masses, and that's the number you see on the periodic table. But that mass number, that average, may not match what you get if you look at one atom of sodium and add up its protons and neutrons to get that mass number. This is the average of all the masses for all the different sodiums. Some sodiums might have more neutrons or less neutrons than another sodium. That's for another time. That's called isotopes. But what you do need to know now is that this number on the periodic table is an average. Mass number is when you look at just one thing and add up its protons and neutrons. You get a mass number. Now, if you take all the different mass numbers for all the sodiums, that's where that average comes from. If we're going to try to calculate protons, neutrons, and electrons, and we're not dealing with isotopes, again, that's another day, what you will do is you will look at the average atomic mass on the periodic table and just round that number to the nearest whole number. So let's do that for these three examples. So the first element I gave you, atomic number 11. And so that turns out to be the element that we were just looking at, which is sodium. So if I know the atomic number, which is 11, then I know the protons and the electrons automatically. If my atomic number is 11, then sodium has 11 protons and 11 electrons. Now, how many neutrons does it have? I don't know. I need the mass number. However, I am not giving you a mass number for this example. So you will use the trick I mentioned. Find sodium on the periodic table and look at the average atomic mass. Round that number to the nearest whole number. Sodium is 22.990. That will round to 23. So the mass number we will use for our example is going to be 23. So to get the neutrons, you will use mass number minus the atomic number to get your neutrons. For sodium, the mass number that I told you to use is 23. That came from the periodic table. The atomic number for sodium is 11. So 23 minus 11, 2, 4, 8, carry the 12 and a whoop-de-woo. That should be a 12 neutrons. And there you go. Now let's look at the second example, and I'm going to try to guide you more. So we're going to look at element number 17. What element is that? If you're looking at my periodic table on my screen, element number 17 is all the way here. What a coincidence! Element number 17 is another one of my favorite elements we talk about all the time. That's chlorine. It's just funny because sodium and chlorine make such a wonderful couple with each other, right? Sodium chloride, table salt, we eat that every day. You need it so that the circuit in your body can run effectively. So number 17 is chlorine. So if that's element number 17, what do I know? Atomic number 17, how many protons does it have? 17. How many electrons will chlorine have? 17. How many neutrons? I did not give you a mass number. So look on the periodic table, read the mass number, the average atomic mass, and round it to the nearest whole number. The average atomic mass written on this periodic table from ptable.com, it says 35.45. That is a horrible way to do that because you're going to say, well, 35.4 That 4 does not make that 5 round out, right? Round up, but you have a 5 here, which would make the 4 round up, which would make the 5 round up. I mean, let's just say 35. We'll leave it at that. So if the mass is 35 for this chlorine, then the atomic number 17, you will do 35 minus 17. What is that? I believe that is 18 neutrons for chlorine. I hope that's right. If I'm wrong, pretend that I'm right. All right, you do number 20. And what I would do is pause the video right now, do it, and then unpause. So I hope that you did it. Who is element number 20? On the periodic table, element number 20 is another popular one. Here it is. That's calcium. Another favorite for our bones. Calcium is element number 20. So what do we know? Protons should be 20. Electrons should be 20. And for the neutrons, you must use the trick. On the periodic table, the average mass of calcium is 40.078, or whatever that last number is. We can say that's about 40, right? So mass number minus the atomic number equals your neutrons. So 40 minus 20 is 20. So calcium has 20 neutrons, right? And that's how that goes. So if you look back at what the goal was for this first video in our series, we want you to be able to count the number of protons, neutrons, or electrons in any atom on the periodic table. Now, it is important to do that because this skill will snowball into all of the other skills, and we will have videos for each of these as well. I hope that this helped, and the more you practice this, the better it gets for you. So I highly suggest looking at some resources, maybe from our Google Classroom, or just doing a Google search for games, practice worksheets, videos, and whatever to help you with this skill and the other skills that we'll be showing you in this video series. Thank you for watching and have a good day.